Hello class, as mentioned in the previous video, so this time we are going to solve some sample problems from physics in application of those formulas that you have seen in the previous video. So number one, we have here the problem. Being Russian is waiting at a stoplight. When it finally turns green, being accelerated from rest at a rate of 6 meter per second squared for a time of 4.10 seconds. Determine the displacement of Bean's car during this time period. Okay, so this is the problem. So to solve this problem, class, so we have to apply the formulas that you have seen in the last video. Alright, so if you are not familiar with those, then it's better to write them down first and then see which of them you can use. But before doing that, let us find out first what are the givens in the given problem. So let us look at those items that are given in the problem above. So in the problem we're given the acceleration, which is 6 meter per second squared. So the unit is meter per second squared, so that indicates an acceleration. So this is 6.00 or just 6.0. So meter per second, that is our acceleration. Then we are also given the time, which is 4.10 seconds. Alright, and we are required here to find determine the displacement. So displacement, so it means that we are going to solve for S. So S here is the requirement, the displacement. Okay, so for our solution, so which of the formula? We just define first the formula that is given in our previous video. We have the velocity. Final velocity is equal to the initial velocity plus acceleration times time. Okay, and we are also given the formula for displacement. Displacement S is equal to the initial velocity times time, then plus 1/2 times the acceleration times the square of the given time, and V squared is equal to VO squared plus 2 times AS. So we are asked to solve for the displacement, so we can use either this formula or this formula. So you have to analyze which of the formula that you can use. Okay, so for our solution here, so we have to analyze the problem carefully. Know that at t equal to 0, so remember that Beans is waiting at the stoplight. Alright, so at t equal to 0, so we can say that the initial velocity is equal to 0 as well. Alright, now if you are going to use this formula, because we're given the time, we're given the acceleration, so it's just a simple substitution, class. Alright, so S, which is the displacement, is equal to V sub O times T plus 1/2 times acceleration times square root of the time. And we know that at t equal to 0, v sub 0 is equal to 0. So v sub 0 times t, so the whole thing here, this whole thing here is also equal to 0, right? Because v sub 0 is equal to 0. 0 times t, that is also equal to 0. So our equation now becomes s equal to 1/2 times a t squared. Then substituting the given, our acceleration, the given acceleration is 6, okay, 6 meter per second squared, meter per second squared, then multiplied by time. Time is 4, so this is equal to 4.10 second, and this is squared, right? So the time is being squared, so we have the second being squared, we have the second squared, so the second squared here will be gone, because second squared divided by second squared, that is equal to 1. Then you square the 4.10, so therefore our s, which is the displacement, is equal to 50.43. Okay, so the unit left here is only meters, because the time in secant squared already gone, no? Secant squared divided by secant squared is equal to 1. So this is our final answer. So S, that is the displacement that is being asked in the problem, is equal to 50.43 meters. Okay, so that's it. That's how simple to solve the problem. Anyway, this is just a recall of what we have learned in physics. Alright, so that's all for this video, and see you again on the second video for item number 2. Bye.